Hi, everyone. Thank you for joining our session today on software supply chain security with Electrosource, Synopsys, and Siemens. So let's start with what you can take from today's session. Building trust in the supply chain starts with securing the software development lifecycle. By designing security earlier in the process or shifting left, securing your code, providing traceability to design assets, and testing your software are all part of the DevSecOps process. We call this methodology shift left, secure, trace, and test. And you've probably heard about SolarWinds and Log4j vulnerabilities, which are commonly referenced regarding security in the design process. These vulnerabilities exploit weakness in software design. So how do you secure your software and what's in it? Today, we'll show you how to secure your software development lifecycle with the leaders in application life management and application security testing, Siemens and Synopsys. How you can build software bill of materials, an inventory of software, and a component library, a framework to remediate, prioritize, and manage vulnerabilities which leak these assets, and why you should do this to implement cybersecurity best practices recommended by standards organizations, such as the ones noted below. The benefits we hope to enable are to help to protect your software customers and your brand, reduce risk and liability in your business, develop cybersecurity leadership in your products and your organization, and develop a competitive advantage that saves time and cost with respect to cybersecurity compliance. So here's our agenda today. We'll start with a brief intro on who, what, and why ALM. Then Steve from Synopsys will provide a little more background on how Synopsys tools solve this problem. Stuart from Electrosource will provide a demo of X-DLM, which is our integration of Polarion with Synopsys Black Duck. And we'll close with a summary and Q&A session. At the end of the session, please type, or during the session, please type any questions you have in the chat window and we'll address them at the end. And we'll also highlight some specific references to the recommendations at the end of the session as to the problems that we solve. Here's a little overview on our presenters today. Steve Shanko is with the Software Integrity Group at Synopsys, a recognized leader in security, rated #1 6 years running by Gartner in the AST segment. Siemens is a recognized leader in ALM and PLM, and we'll be showing you an application and template that we've implemented in Polarion with Synopsys tools. And Electrosource is a technology alliance and sales partner for both Siemens and Synopsys. We provide services and develop integrations with extensions for tools, and the one we're going to focus on today is called Virtual Fidelity X-DLM for software bill of materials and vulnerability management. My name's Peter Anzelmo. I'm with business development and sales here, and Stuart Turner leads our engineering department. So let's look at why ALM and AST and what problems can we solve. The first is risk and liability. There's an increasing dependency on open source software, and Synopsys publishes a report called the Open Source Risk Analysis Report. And in that report, 2,400 code bases were audited by their Black Duck tool. The results showed that 97% of these code bases contained open source code, 81% at least one vulnerability, and over half of the code bases had license conflicts. This represents a risk to the business if these elements are left unchecked. The next reason is transparency and traceability. This is recommended and required in functional safety design. It was estimated in 2018 that about half of the software stack originated from open source code in automotive designs, and today it's estimated to be over 65%. Continuing on automotive, the NHTSA updated best practices for cybersecurity design in modern vehicles. They recommend SBOMs to manage software, along with NIST's SSDF framework, ISO's 21434 guidelines, and the cybersecurity framework from NIST as well, which clearly outlines vulnerability management as one of the solutions required. These documents also recommend AST tools like fuzzing and pen testing, along with threat modeling. And the FDA is also making cybersecurity part of quality and safety in their QSR regulation. They recommend producing what's called a secure product development framework. And that framework encompasses transparency in testing, SBOMs, and application security tools, which are all recommended as part of this process. Polarion and Synopsys are leaders in both automotive and med dev design to help to trace this data. And the third reason is evolving cybersecurity frameworks, mandates, and recommendations. For example, Executive Order 14028, which recommends SBOM as part of the software security supply chain solution. There's a document called the NTIA Minimum Elements for Software Bill of Materials. It's an implementation guide that we've used and that Stuart will show you in his demo to produce software bill of materials. NIST has also provided two key references, the SSDF that I mentioned earlier, or the Secure Software Development Framework, and the Minimum Software Verification Guidelines. Both these documents outline application security tools you should use to secure your software, and Steve will show you what those are in his segment. And finally, something called the Enduring Security Framework. It's a best practice guide on securing the software supply chain for developers. It also includes references on SBOMs, application security tools, as recommendations. So that brings us to how we can manage these elements to secure the supply chain. Our X-DLM solution is an integration of Siemens Polarion ALM and Synopsys AST tools. It enables customers to provide traceability of secured assets in a center of truth. In the demo coming up, Stuart will show you an application that connects these tools along with a template that we've developed. So let's take a look at how these dots connect. The cybersecurity guidelines, recommendations, and standards mentioned earlier will require traceability, and some of them will actually become formal requirements. They'll need to be validated in the system and software design process, and Polarion provides an excellent test and requirements management framework to do this. The vulnerabilities mentioned earlier will need to be managed and remediated in a workflow. Stuart will show you this in the demo coming up. And the elements of the project managed in a center of truth to provide evidence for compliance. A V model or an agile project workflow is often used, and we can help you implement that with Polarion templates. Synopsys provides a suite of tools and services to secure the software, starting with threat modeling and building security in the maturity model, or BSIM. This is about shifting left in planning for use cases and security assessments to achieve the desired objective for security in one's architecture. Software composition analysis is about scanning your software so you know what's in it. Synopsys' Black Duck tool is an industry leader that provides SBOM's license compliance and security advisories for vulnerabilities. There's also different types of AST tools, such as static, dynamic, and interactive, for example, to secure code as it's written, and also APIs. And finally, fuzzing and pen testing to secure system interfaces from potential attack vectors. So at this point, I'll hand over to Steve. His session's recorded as he's traveling to Taiwan this week, and then Stuart will provide a demo of SBOMs with vulnerability management and Polarion interface with X-DLM.
Thanks, Peter. Synopsys is dedicated to tackling these software supply chain challenges head-on, and we're uniquely positioned to do just that. Let's take a look at the following presentation to find out why. First of all, Synopsys has deep expertise in industry. We started out in silicon design and verification, and interface analog and embedded memories and physical IP. So we're experts in the hardware space, and we're also #1 in the application security space, which means we understand how hardware and software interact together to produce security or a lack thereof. We're a stable company, which is very important in these economic times, and we've been tackling these problems for a long time, and we intend to continue doing so far into the future. In case you don't take my word for it, we're the recognized leader in application security testing across Gartner and Forrester, so the analysts would agree, and if you get out there and talk to your customers, I'm sure many of them will be using a mixture of Synopsys solutions to address their toughest security challenges. Synopsys has a full portfolio of tools across the entire application security suite in order to address the varied needs at different points in the software development lifecycle, and also the varied needs of different interoperability between the systems that you're composing. So let's take a look at what one of those systems might look like. This is a simplified IoT system with sensor, edge, and cloud components. you can see there's an edge device with an operating system that has proprietary code, APIs, secure boot, CPUs, other embedded cores and devices. There's a gateway to connect out to the internet via Wi-Fi, Ethernet, or LTE. And there's a sensor stack with an MCU as well. These are all communicating over different protocols using different APIs. We can see CAN bus, Bluetooth, and Thread are involved. Gosh, it is a complex environment that we see here, but Synopsys tools actually apply to all facets, whether it's the communication between these systems or the applications running within the systems themselves, on those CPUs and on that hardware. We address security through all phases. So how do we do this? Looking at how a modern application is built, again, there's going to be a healthy layer of open source. On top of that, there's going to be some proprietary code that you're developing, which is the secret sauce, if you will, to your business's success and to your value proposition in the market. And the reason open source is so popular is because it lets you spend more time working on that proprietary secret sauce, and it allows you to leverage a lot of functionality from the open source community. However, we have to think about tracking and managing that open source use and security and license compliance risks that might come along with it. Similarly, in the proprietary code, your developers may also introduce defects here, which can have certainly security and quality implications for your devices. Once we've established the code and created something that can actually be compiled or built and run on a device, on a physical hardware device, how do we know we've addressed runtime vulnerabilities, data protection issues? How do we make sure that the protocols and APIs our software exposes aren't vulnerable to common hacks? And Synopsys covers all of these. We're going to be focusing on Black Duck today and the open source software and software composition analysis piece. But we also have static analysis for the proprietary code. We have Seeker and White Hat interactive and dynamic analysis for typical HTTP web interactions and the dynamic analysis of those applications. And we have Defensix, which specializes in protocol and API fuzzing over a great deal, many more protocols than just HTTP, things like CAN, Bluetooth, and Ethernet, just to name a few. And Synopsys also thinks about how we integrate and optimize all of these different tools throughout the software development and verification process. In case you haven't heard, there is an executive order on improving the nation's cybersecurity. And based on that executive order, NIST has come out with some standards and recommendations on what a software development lifecycle should look like. So we borrowed this from NIST, this graphic actually, but the important thing to note is that the Synopsys solutions really overlay on every phase of software development, all the way from planning through to verification, testing, deployment, and operation. Now let's talk a little bit about SBOM. It's the elephant in the room. Everybody wants to know about SBOM, mainly because there are, again, the executive order and the NIST standards that specify you must provide a software bill of materials. But what exactly is an SBOM and what isn't it? So an SBOM has tracking over your open source dependencies, custom components, binaries and firmware, and third-party libraries. It's a list of application ingredients, if you will. Think of it as the label on the back of your food package that tells you exactly what is in that item. What it isn't is vulnerability, risk, or implementation insight. Let that sink in for a minute. There's a lot more here to care about if we're talking about securing the software supply chain than just simply creating an SBOM. Although creating an SBOM is great and is very important, especially for compliance purposes, there's a lot more we can do to ultimately mitigate risk and be aware of potential vulnerabilities our software might be exposed to. Again, SBOM is one part of software composition analysis, and it's one part of what Black Duck by Synopsys can do. We're looking at the inventory function of software composition analysis, which is identifying and tracking all of the open source in your apps and containers. However, there's more we can do. Once we know what that full bill of materials looks like, we can think about finding and fixing known vulnerabilities, We can think about adhering to license compliance and license terms. And we can think about a broader governance over the software design and verification process in order to automate more of these heavily manual tasks that we have today. Black Duck generates the SBOMs during development, during different phases of development, starting at the coding phase, but we can also analyze the software during build, test, and even monitor and continue to alert into the operational phase of your program. We do this through a mixture of different techniques that allows us to not just do simple dependency analysis that many of our competitors do, but to also look at code prints, snippets, and binary analysis as well. And building trust in software ultimately is a journey. All of these items in the software supply chain are inextricably linked together, and it is incumbent upon us as providers of OEM products to make sure that all the links in these chains are strong. From open source to proprietary code to containers and infrastructure as code, through to the way that we design and implement our protocols and APIs and how the application ultimately behaves. All of these things are critical to user trust, and if one of those is missing, we're going to have a problem. And ultimately, we also add an additional layer of management across all of these pieces using our CodeDX product and security and consulting services. If I can leave you with a few key takeaways on Black Duck, it is the most comprehensive open source risk management on the market. It has multi-factor discovery to find all of the open source in your applications and projects, which is critical to building that comprehensive bill of materials. Black Duck has the most comprehensive knowledge base of vulnerability, license, and operational data on these open source components that you use. We have enhanced vulnerability data with same-day notifications and more insight than the National Vulnerability Database. And we have end-to-end integration into your DevOps workflows to automate the discovery and policy enforcement of all of these open source issues throughout the entire software development lifecycle. Now that we've got a better idea of how Black Duck helps meet these needs, Stuart will show us how the Virtual Fidelity X-DLM solution leverages Polarion and Black Duck to automate the security design process and to elevate the value above just merely the SBOM to pulling in really risk information. So thanks, Stuart.
Thanks, Steve. Now I'm going to show you how to automate your software bill of materials with Synopsys Black Duck, Siemens Polarion, and our Virtual Fidelity X-DLM solution. First, X-DLM will automatically be executed by the Polarion scheduler and retrieve the software composition analysis created by Synopsys Black Duck. This alleviates the time-consuming, error-prone task of trying to incorporate this data manually. Next, X-DLM will automatically create software bill of materials reports in Polarion in various NTIA compliant human readable formats. This expands the understanding of software supply chain management beyond the realm of engineer. Then we'll show you vulnerability related information and reports. These help to automate monitoring and managing vulnerabilities that affect your SBOM. It also helps to accelerate remediation and reduce your risk exposure. We'll be using Black Duck security advisories, BDSAs, along with common vulnerability and exposures, CVEs, to create these reports. Finally, X-DLM also creates a library of software components in Polarion for traceability and version control. This SBOM library of components can be used for organizations to manage contractors, projects, or an inventory of software for the company. This is Black Duck from Synopsys. It's a project-based environment that connects to a project in your code repository, like Git or SVN, and populates the corresponding Black Duck project with information on the software components used, identifies the associated vulnerabilities, and offers various types of capabilities such as risk analysis and SBOM generation. Let's look at the Black Duck data we'll be synchronizing with Polarion. For this demo, I'll be focusing on the Duck Hub demo project. In the project, you can see a summary of the risk Black Duck has identified, as well as all the software components used in the project. Clicking on a component, we can see more information about it. Components have an approval workflow as reflected by its approval status. The component approval workflow will be synced with a corresponding component in Polarion, allowing it to be part of your ALM process. Back on the project page, clicking on the Security tab, we see all the vulnerable project components Black Duck has identified. You can select a component to see its associated vulnerabilities. Clicking on a vulnerability provides more information, including remediation. The remediation workflow will be synced with the corresponding vulnerability in Polarion, allowing it to be part of the Polarion workflow. Let's look at how the Black Duck project is reflected in Polarion. I've created a Polarion project using an X-DLM Polarion project template to link to the Black Duck Hub demo project. To hold the data from Black Duck, I've created some Polarion work items. I have a component work item and a vulnerability work item. The Polarion scheduler has already executed X-DLM to retrieve, create, or update all the software components and vulnerabilities from Black Duck. You can imagine the amount of time it would take you to manually create these items, fill out the fields, link them together. X-DLM automatically takes care of that for you. Looking at a component work item, we see the title and a description. The status field is synced with Black Duck and allows you to manage and monitor the component approval workflow. There are several fields to hold NTIA compliant information about the component, such as supplier, version, licensing information. I'm just showing some basic fields, but you can add as many fields as required depending upon the information you need from Black Duck to achieve compliance. All the components and vulnerabilities have a link back to the corresponding item in Black Duck for reference and more detailed information. The vulnerability work items are named after the type of vulnerability it is, which could be a common vulnerabilities and exposures, CVE, or a Black Duck security advisory, BDSA, as we see here. The BDSA is based on data from the Cybersecurity Research Center and offers deeper coverage than the CVEs typically found on the National Vulnerability Database. The vulnerabilities have a field to indicate the severity Black Duck has assigned, and the status field is used to reflect and manage the remediation workflow. There's a description and then more information about the remediation. Since remediation is a dynamic activity, X-DLM makes sure Black Duck and Polarion are always in sync with each other. Besides populating the project with components and vulnerabilities, X-DLM automatically links each component to any dependent components and related vulnerabilities. This creates traceability between the items, allowing you to tie these into your overall Polarion workflow. Polarion live docs and widgets are useful for creating NTIA compliant SBOMs and reports to track your cybersecurity compliance status in a readable format that is easily understandable by both engineering and management while providing traceability throughout your software supply chain. X-DLM automatically creates and populates a configurable live doc SBOM, displaying the NTIA compliant fields for each component. Child-dependent components are indicated by an indentation. Approval and sign-off of the SBOM is accomplished with Polarion's e-signature capabilities. We utilize widgets and dynamic report generation to display information in any format, such as SPDX or Cyclone, as required to show compliance. Here's a simple SBOM for the project containing the minimum fields for NTIA compliance. Here's an X-DLM vulnerability report that shows vulnerability distribution by severity and remediation status, as well as a table of vulnerabilities and their related components. The table is filterable by remediation status or by severity. X-DLM creates and maintains a global library of components used in all projects. This is useful to ensure compliance and traceability throughout your entire software supply chain. There are several views available in the component library. There's an inventory of all the project SBOMs with the project, title, status, and update information. You can navigate directly to any SBOM from this view. This is particularly useful when there's more than one project related to a product, allowing you to monitor the SBOM status for the entire product. The component table view shows you all of the components in the library and where they're used. This helps you track and ensure a component and its related vulnerabilities have been remediated in all the projects that are impacted by use of that component. You can also filter the table by the component's title. In the Where Used view, we use a widget to provide a graphical trace for a component's usage. We can use the title or the work item ID. We can see the components throughout the projects as well as the connected vulnerabilities. And now, back to you, Peter.
All right, thanks, Stuart. So obviously that was recorded as well, just makes it cleaner in terms of transitions. Let's go to a summary here, and then we'll wrap up with some questions and some references to what we just talked about. So hopefully we showed you today how you can secure your software supply chain, starting with secure software development lifecycle with transparency, traceability, and security in your designs, with ALM, or application life management, application security testing, software bill of materials, and vulnerability management that Stuart just showed you. In terms of next steps, a lot of customers look at, how much do you need? A lot of these things are not mandated. The EO is about mandates if you're doing business with the US government, but these are becoming best practices to try to solve these cybersecurity problems. So do you crawl, walk, or run? And there are assessments available for you to do that. Also, there's point tools that we just showed you that you can take as much as you need and start with things like software composition analysis to develop these SBOMs. So, that brings me to the next point, which is application security testing is often referred to as a journey versus a destination. There's something called the Building Security and Maturity Model. It's on the Synopsys site. I can send you a link to that. And it allows you to kind of do an assessment of what your security goals are and to assess what you need in that walk, crawl, or run type assessment. Siemens has a great template called the Siemens Intelligent Design Control Methodology. They have medical design templates, automotive templates, things to help you get traceability and transparency in your design process. And we can mirror those with this SBOM template that we've developed to help you develop that vulnerability management in your software development lifecycle flow. And of course, X-DLM combines these tools to create that SBOM and vulnerability management flow so that you know what's in your software. And really, that's the problem that we're trying to solve, right? What's in your software? How do you know what's in it? What kind of vulnerabilities are in it so that you can find and fix them? And that brings us to the last point, which is the benefits to reduce risk and liability in your business. Time to market and cost. It's harder to do these things afterwards and often more expensive. And, as cybersecurity becomes more important in the market, differentiation and leadership in your products. So we'll just kind of link these to the recommendations. This is the NTIA minimum elements document. I'm not going to read through the whole thing, but this is what's recommended by EO 14028. They describe what an SBOM is and why you should have one. So I just want to show you some key highlights as to why this is important and where this information came from. This is according to CISA, right? They call it as a supply chain risk management. NTIA, the necessary glue to allow relevant external, and usually this is open source software, but also it could be related to software built in-house. The point here at the end in green, most notably the potential to track known and newly emerged vulnerabilities and risks. So with the demo that Stuart showed you, you can take these Black Duck security advisories that have a little more information than the CVEs, a little more depth, and then you can put them in a remediation and a priority flow to build reports in Polarion. And that's what we're doing with our solution. So here's something from the minimum software verification guidelines that I mentioned earlier. Threat modeling, which is about shifting left, some of the use cases that you need to build for security in your products. For instance, in automotive, right? How do you do OTAs, or what happens if somebody breaks in through Wi-Fi? Can you fuzz the interface, and what kind of threat modeling? How does it affect the rest of your system? Automated testing, static code is called SAST. Heuristic tools to and in addition to black box test cases, Polarion has an excellent test framework in the tool to help to provide traceability to these things. And then at the end here, you'll see something called fuzzing. That's the idea where you throw things at the interface to try to break it, and is highly recommended by some of these documents. SAST, application security testing, traceability, they're all part of these recommendations. Continuing on, the secure software development framework, they have 4 key pillars: preparing the organization, protecting the software, producing well-secured software, and responding to vulnerabilities. So hopefully we showed you some of the things that we could do with our platform. And here's the ESF that I mentioned earlier as well. So they also mention static and dynamic application security testing, software composition analysis. We showed you these tools, and the vulnerability management in our flow, along with fuzzing. These are all Synopsys tools that can be traced in the center of truth with Polarion, and then managed through the workflow in our X-DLM solution that we showed you. And finally, the NHTSA, they reference at the bottom here, you'll see the references to ISO 21434, the NIST publications, 427 here, the third point, which is cybersecurity testing and vulnerability identification. This is about knowing what's going into the ECU, and an inventory of management of hardware and software assets, which is from 426 of that document. So that brings us to questions. Here are the links. Here's my email. If you would like references to any of these documents, please send me an email. The presentations will be loaded and hosted for the next week, we understand, and then on demand. We could also send you the presentation if you'd like and answer any questions. So at this point, I'll open up the chat window and see what questions we have. Stuart, are you able to see any questions in the chat window?
Yeah, so far there are no questions. Okay. One question: how does this solution differ from the solution that was presented yesterday by Sigrid?
Okay, so I'm not as familiar with the Sigrid solution, but what we're trying to enable is, first off, Black Duck is an industry gold standard for software composition analysis, and companies actually use it not only for the software composition analysis part, but for license compliance. What we do is we take that with the Black Duck security advisories. Black Duck security advisories are from Synopsys' Cyber Security Research Center. And what they do is they provide more depth to those CVEs. They have a group that actually looks into them, provides more insight to the vulnerabilities. And we use those in our workflow. And then you take that workflow, putting it into Polarion, that gives you a template for not only the software composition analysis piece to give you SBOMs, but to allow you to sign them off internally so that you can prove some kind of attestation. And then furthermore, the vulnerability reports that you can do from, let's say you had an inventory of software for your products and you want to know, where is this software used? There's a vulnerability associated with Log4j. You could put in where used in our X-DLM template and find out where that vulnerability or where that software component is used so that you could find and fix the vulnerability and also track it in the workflow. So hopefully that answered some of your question, but there are a lot of elements to how they might be different. And then the last piece is that our first implementation is for SBOMs, but Synopsys provides the full tool suite. So that includes static, dynamic application security testing along with fuzzing, which can be used as part of this process. Okay, another question would be on cost. So we price the solution according to users, and also it depends on if you have Polarion or not, whether or not you have Black Duck, and we basically put together a price based on number of users and the implementation required. And another question on availability. Availability of the solution is, so Black Duck, of course, is a production-ready solution enterprise class, as is Polarion, and they can be used standalone or with our solution, and our solution is ready for customers in a beta state. Okay. So if there are no more questions, we'll conclude the session. Thank you so much for attending. We appreciate it. This will be posted. And if you have any other questions or any other requests, please send me an email and we'll be happy to address them. Thank you, everyone, and have a great day.